drop an effervescent vitamin C tablet in water and measuring the rate of reaction through various methods, for instance, pH, volume of evolved gas, or mass. We devised a way of experimentally calculating the rate through gas evolution and generated data for the interpretation by measuring volume at routine time intervals.
The procedures for our experiments are the steps below. Number 1. Make sure all the reactants, glassware, and measurement tools are in reach and ready to use, such as the Erlenmeyer flask, water, electronic balance, vitamin C tablets, and volume measurement apparatus. Locate the 250 ml Erlenmeyer flask, and in the flask add roughly half a cup of water. Step 3. Measure the mass of the tablet and water on an electronic balance for later calculations. Step 4. Drop the vitamin C tablet into the Erlenmeyer flask with the water. Step 5. Secure the measurement apparatus on the flask. Step 6. Every 10 seconds, record the volume displayed by the electronic balance and create a table and graph to go along with the data.
By measuring the volume of gas produced by the reaction, one can determine the change in the volume at a set time interval, allowing us to find the rate of change of reaction. When the tablet is dropped in the water, the reactants are allowed to react. One of the products of the reaction is CO2 gas, and we can measure the volume of gas by using a gas volume measuring apparatus, which in our case was a stoppered flask with tubing leading to a syringe. The pressure in the container would build up and consequently push the syringe outward until the pressure reached an equilibrium. Let's go ahead and take a look at some of the clips from when the lab was being conducted. The way we will know that the reaction has occurred is if at least one of the following conditions are met: a change in temperature, an evolution of gas, or a precipitate being formed. Out of the three main criteria that state conditions for whether a reaction has occurred, only one bar was met, an evolution of a gas, presented as a formation of bubbles. Given that on contact with water, the effervescent tablet produces a gas, we know that there is a reaction that has occurred within the contents of the tablet, keeping in mind that the tablet is not pure ascorbic acid, as it has filler material and other binding agents. According to the active materials seen on screen, the effervescence of the vitamin C tablet is due to the acid and base reacting when in the presence of water, as it provides a medium for ion transfer. The acid and base are citric acid and sodium carbonate respectively. Like most organic acids, citric acid is available to exist in a desiccated form.
The reaction that is occurring to produce the gas is a neutralization reaction between the different substances within the vitamin C tablet. The tablet includes 1000 milligrams of ascorbic acid as well as an unknown mass of effervescent binding material. According to the manufacturer of the tablet, it contains both an organic acid and a base, specifically citric acid and sodium carbonate. The neutralization reaction is on the screen. The reaction is between sodium carbonate and citric acid, which forms carbon dioxide, sodium citrate, and water.
We can find whether the reaction has stopped based on several different factors. We know that the reaction's product is a gas, and due to this, it bubbles out of the solution. Therefore, we can see that the reaction has stopped when the bubbles stop being evolved as a result of the reaction. Another indication that the reaction has stopped is when there is no more observed gas production from the solution. This can be tested with a stoppered Erlenmeyer flask connected to a syringe to measure the volume of the gas produced by the reaction.
The rate of the reaction is not the same at the beginning and the end, because at the start of the reaction, the reactants are available in abundance. Therefore, the reaction is happening at a higher rate at the beginning, whereas near the end of the reaction, the reactants have reacted to form products. Means there are fewer reactants available, which would result in a slower reaction rate.
I think because it was like rubbing against the phone, but
In conclusion, we found out that the best method to measure the rate of reaction was by calculating the volume of gas evolved by solution. The gas produced by the solution was carbon dioxide and was produced from the neutralization of sodium carbonate with citric acid. This yielded the products of sodium citrate, CO2, and H2O. It is important to note that the tablet did not react with the water. Instead, the reactants were in a form in which they couldn't react. However, the water allowed for them to. Measuring the volume at routine time intervals showed that the reaction rate is not constant, due to factors like the concentration of reaction changing as the reaction progresses.
just this is like. Oh, okay. So hold on. Scientist guy. So the bubbles are trapped under the water, and we shook it so the bubbles were released. Then the bubbles.
Is this gonna be in the video, the scientist guy thing? What the hell? We're probably not gonna put this in the video though. Yo, well, I'd like a section of like funny moments, you know, bloopers. Yo.
Shake is light.
Trig is